Are you listening? Transformations, it's the most important concept you'll ever learn about life. And about math methods, VCE, transformations, you gotta know this. Dr. T, dilations, reflections, and the other one, translations. You gotta know how they work. You have to know. This is like the first thing that I'll teach you. This is the only thing that you need to know to like ace the whole course, right? Transformations. Now, transformations. You know there are 3 types of transformations: dilation, stretch factor, reflection, we all know what that is, and translation, which means pick it up, move it left or right, up and down, okay? 3 different things. So there's really only just 3 things that you gotta look for, and it could be inside or outside, so there's basically 6 different combinations that you could possibly have. So make sure, listen in, get this down. This is the only thing that you'll ever need to learn. If you don't learn anything, learn this, okay? This will make your teacher look real dumb. All right, so here's how it works. I'm going to give you this. I'm going to give you f of x plus 2 and f of x plus 2. Now, I'm going to ask you a very quick and very simple question. Inside or outside? You may not know the answer, but I want you to just answer me with whatever makes the most sense to you, whatever that is, intuitive to you. F of x plus 2 and f of x plus 2. Now, if I was to ask you the question, inside or outside, I want you to just yell out the answer, okay? Inside or outside? That's right, inside. Inside or outside? Outside, right. You get this, okay? So I want you to just be clear about, is this inside or is this outside? This is the key. This is the key. Okay, so inside. By the way, if I had let's say a 2 here, that's inside. If I had a negative here, that's all inside. If I put a 2 out here, that's outside. If I put a negative out there, that's outside. And there's huge differences between the two. Here is the difference. Okay. Inside, left, and right. Can't be stuff right. Left and right. So anything that's inside goes this way. So anything that's on the inside of the function, it moves left or right, it stretches this way or reflects this way. Okay? And by the way, that reflection, it's called reflection across the y-axis. Okay? They're very technical with this language, so you better get it down pat. Reflection across the y-axis. And this is dilation away from the y-axis or parallel to the x-axis, okay? Whereas outside, it's up and down. I usually say outside towards the sky, right? It goes up and down. So up and down. Okay, this is important because you want to know which way to move the graph. And if it's all inside, guess what? This ain't gonna move, it's all this, right? So this is the key. Inside, left and right, outside, towards the sky. So keep that in mind. And by the way, inside, it's always the dodgy one. It's always the one that's like the opposite, like tries to be cool and tries to do something else to be cool. Always the opposite. Inside, dodgy, okay? So this is where like 99.99% of people make the mistake. It's on the inside, okay? So watch out for when it's on the inside. All right, let me go through an example with you. All right, so let's say we have a little, let's say we have an equation. Let's do a parabola. We all know parabolas, right? F of x equals, parabolas. Okay, we got this, x squared plus 4. Let's put a negative out the front. Okay, so there are 2 transformations right there. And they're both on the outside. As opposed to this, bracket negative x squared, that will be on the inside. So there's a huge difference. Just watch out for that. Okay, so what does that do? Well, outside, it's towards the sky, up and down. That reflection, instead of looking like this, it now looks like this, right? You get this. And plus 4, what does it do? Translates 4 units up. Now it looks like that. That's it. So in terms of transformations, that's easy. And you get it. And what if it was a 2 out the front? Well, that's a dilation factor or a stretch factor. A dilation factor of 2, so it's twice as tall. Don't do that skinny thing with me. I know your teachers taught you, oh, it's thinner. No, it's not, okay? Just because someone is twice the height of a normal person doesn't mean they're skinnier, it just means they're taller, right? They may look skinnier in terms of proportion, but it is totally wrong to say that they're skinny. Totally wrong. So when I put a 2 there, that's dilation up and down. Stretch factor, dilation factor of 2 parallel to the y or away from the x-axis. Okay, I want you to get this down pat because I want you to be able to write down exactly, technically, the technical jargon of how it's being transformed. You got to do this. So it's a dilation factor of 2 away from the x-axis or parallel to the y. Alright, so you get that. But the trouble is when you have things on the inside, they're usually the pain in the ass, right? You have things like this. For example, exponential graphs. E to the power of, let's say, negative 4x plus 2. Okay, now that is a pain in the butt. Huge pain in the butt. In fact, I'll make it easier. I'm going to put brackets around this, and that actually makes it a lot easier. So this is one of those little tricky things that you've got to watch out for, probably later on, not so much now. So we got 3 transformations here, 3 of them, all 3 of them, okay, and they're all on the inside, okay, because outside would be here and here. That's inside, left and right, okay. So exponential graphs, oh yeah, I get exponential graphs. It looks like that without that little kink in the graph. Okay, negative 4. So negative, what does that do? Well, that's a reflection left and right, right? So instead, now the graph looks like this. Okay? What does the 4 do? Now the 4 is tricky. It's inside. Remember what I said about the inside? It's always the opposite. So it's not a dilation factor of 4 stretching it this way, but rather it's compressing. It's compressing. So it's more so like a dilation of a quarter, okay? So this is a dilation of a quarter. Make sure you take notes on this. This is the key. This is where 99% of people drop the ball. They just totally screw this up. It's a quarter, okay? So it's not getting fatter this way. It's actually, this is skinnier. This is actually the proper skinnier. It's getting thinner, right? So it would look more like this, okay? So instead of this being out, let's say at negative 12, now it's a quarter of that, which is negative 3. Obviously to scale, right? So it's a quarter of that. Now, the plus 2, what does that do? Opposite goes left 2, negative 2. So you will probably know this already. So everything moves 2 to the left. Okay, that's pretty simple. But it's these 2 things that are the thing that most people screw up on. So transformations, the first thing you've got to ask yourself is it inside or outside? And which one is it? Dr. T, which one is it? And for the people who don't know who Dr. T is, he's awesome. Going in? I'll be out in 2 seconds.
Oh, you don't want any of you?
Now I'll come in. Dr. T, dilations, reflections, and translations. That's what they stand for. So, like, this affects everything. Know your transformations, know them well, know them back to front, and they'll help you with drawing graphs, getting the domain range, and actually having an idea of what the function looks like before you even do the question, which is a huge skill in if you want anything above like a 10 study score in math methods. So, go home, do some homework, and I'll talk to you very soon.